Hi everyone, we're going to graph this function and test for continuity at x equals 0 because that's when the graph is changing at 0. So the first thing we're going to do is test for continuity at x equals 0. Now, the definition of continuity is you have to follow these three conditions. So the first thing is f of c exists. In our case, our c is 0. It's always where the change is occurring there. So f of 0, and we're going to have to pick the lower portion because that is where it's equal to 0. So plug in 0. The absolute value is 0 minus 2, which equals the absolute value of negative 2, which equals 2. So it does exist. It exists at 2. That's your y, by the way. So this works. Now we have to check condition 2. That means what's going on what's happening on the left side of 0 of the graph versus the right side of 0 on the graph. So let's write that out. We have limit as x approaches c from the left, all right, and f of x. And then, does that equal the limit as x approaches c from the right of f of x? So basically, we're going to plug in f of 0. So when you plug in f of 0 from the left, that's going to be the numbers less than 0. And so that's going to be plugged in here. And when you plug that in, you get 0 squared plus 2, which equals 2. And we already did the part from the right. And that part equals 2 as well, because we did that right there. So we do have 2 equals 2. Since we do have these two equal each other, that means condition 2 holds. Now condition 3 just means that the limit as x approaches c, which is 0 for us, of our function, equals f of c. So this limit we just did is 2, and f of c is 2. So that means this function is continuous. All right, so let's graph it. We have at x is less than 0, means I go to 0. I go ahead and plug that in, and I go to 2. Now that's an open interval there because it can't equal 0. Now negative 1, because we're doing the values less than 0, this is on the left side of 0, you're going to get 3. And if I do 2, negative 2, that's going to be negative 2 squared is 4 plus 2 is 6. So this is 3, 4, 5, 6. So it's up in there. So it's something like this. It's a quadratic equation that got shifted up by 2 basically. But we're only doing the left side of the 0. Now this one we're going to do 0 and the right side. So we already did when x is 0. So when x is 0, we had 0 minus 2, absolute value of that. That equals 2. So at 0, we go up here, and it can equal it. So you shade that. Closed overrides open interval. All right, now let's try 1. If we plug in 1 right here, 1 minus 2 is negative 1. Absolute value of negative 1 is 1. So that goes to 1. All right. And if you plug in, let's say 2, you're to 0. You plug in 3, you're back to 1. So here's your graph. This is at 2. So it looks like this. Absolute value function. And you should know what the absolute value function looks like. This is colored in there. You should know what it looks like because of this is just a horizontal shift to the right by 2. So that you can see the function is continuous because we can draw it here and not lift our pen when we draw it. So we got a curve here, and then we have a straight line here. All right, and we didn't have to lift our pen to draw that. And that's it. Oh, we have to evaluate. So evaluating at -4, that's this upper portion. So -4 squared is 16. -4 squared plus 2 is 16 plus 2 is 18. At 0, we already did that. At 0, it's 2. And we also did 1. At 1, you'd have absolute value of 1 minus 2, which equals the absolute value of -1, which equals 1. And that's it. Thank you. Have a nice day. Bye-bye.